Hey guys, Mr. Middleton here. Today we're going to talk about areas of regular polygons. In this video you should be able to find the area of a regular polygon using special right triangles. Let's jump straight into it. Notice above. Alright, am I right? Sweet. Okay, notice the figure above is a regular polygon. Still kind of tilted, hold on a second. And we can tell it's a regular polygon because we know it's a regular polygon. We know that all of its sides and all of its angles are congruent. Okay, the middle of the polygon is called the center here. And each blue dotted line represents a radius, which is the distance from the center of the polygon to a vertex. Okay? Vertex. The red dotted line is called the apothem. And I'll usually call it apothem because that just naturally rolls off a little bit better. This is a segment from the center that is perpendicular to a side. Notice what one apothem and radius form. So if we see this apothem, this is just one drawn, there's a bunch of them. This apothem, this radius, form a right triangle. Okay. In the figure above, we're going to talk about central angles now. In the figure above, angle 7 is a central angle. Okay, it's an angle created by two radii. Okay. So that's a central angle. Alright, how many central angles are there in a hexagon? Well, there's 1, 2, 3, 4, 5, 6. Which makes sense. A hexagon has 6 sides. It has 6 central angles. Okay, how about an octagon? Well, an octagon has 8 sides. It will have 8 central angles. If all the central angles come together at one point, the center, all those angles add up to, what's the shape that we just drew counting out the central angles? Circle, so 360. So in a hexagon, what is the measure of each central angle? Well, we know that they all add up to 360. We know there are 6 of them. So 360 divided by 6 gives us 60 degrees. Okay, in an octagon, we could do the same thing, 360 divided by 8, and that will give us 45 degrees. Okay, the apothem cuts each central angle in half. So the measure of angle 8 will be 60 divided by 2, or 30. Okay, this should kind of clue you in, like, hey, we have 30, 90, 60, a 30, 60, 90 triangle. Probably have to use those. And you'd be right if you thought that. Okay, so let's find the area of a regular hexagon below. They want us to leave our answer in simplest radical form. Okay, so they gave us a triangle with the apothem here. It's a hexagon, so not a whole lot of new work for us because we can say, hey, this is going to be 30. Okay, we know that the central angle 360 divided by 6, 60. Apothem cuts that in half, makes it 30. It's a 30, 60, 90 triangle. In order to find the area of this triangle, I already have the base, which is 10. I need to now find the height. In order to find my height, I'm going to redraw this triangle out because that makes it easier for me. Okay, I have this 30. I know this is going to be x. This will be x radical 3. This will be 2x. Okay, so I need to find this height. That's x radical 3. That's 5 radical 3. So that's my height. The area of a triangle is 1/2 base times height. I know that my base is 10. My height, I just found out, is 5 radical 3. So 1/2 10 times 5 radical 3 will give me 25 radical 3. That's the area of one of those triangles. Now, how many triangles are there? There's 1, 2, 3, 4, 5, 6. congruent triangles in a regular hexagon. So I can do my area of one triangle times 6, which gives me 150 radical 3 centimeters squared as my area, simplest radical form. Okay, all right. Flipping to the other side to continue this thought process. Notice from the previous problem, how many congruent triangles are there in a regular hexagon? There were 6. Okay, if we find that the area of one of those triangles, we can multiply that by the number of triangles to find the area of the polygon. But is there an easier way? Okay, area of one of the triangles, we took that to be 1/2 the apothem, which was the height, times the side, right? And the side length was, in this case, 10. So we did that here. 1/2 the apothem times the side length. Okay. Invisible. Okay. Okay. All right. So that's what we did on that front side. Now, what we're going to do is we're going to recombine this in a different way. We're going to do, instead of doing 1/2 the apothem times the side length for the area of a triangle times 6, we're going to move it around and say, what if we do 1/2 apothem, and I want to group this as 6s. Okay, so still doing the same thing, I'm just grouping it a different way so we can notice something. If we take 6s, in this case, remember that s was the side length. S was the side length, 10. If we take 6s, what will that be for this figure? Well, one side length was just a side. 6 side lengths, in this case, would be the perimeter. Okay? It would be the perimeter of the polygon. I think that was my last time flipping that over. Let me keep all this in the same thing. Okay, it would be the perimeter of the polygon. Perimeter. Okay, therefore we could find the area of the regular polygon by taking 1/2 the apothem times the perimeter. And that is our formula. Area of a regular polygon equals 1/2 A times P. Okay, so we're going to find the area of these regular polygons. And leave them in simplest radical form. So, things that are important for us to have. Well, first of all, we should identify a center even if they don't give them to us. Actually, for this triangle, we should see this as 20, 20, 20. What kind of triangle is it? It's an equilateral triangle. Okay, so I'm going to do 60, 60, 60. Okay. Now, we don't necessarily... I'm not going to use this formula for this problem. I like this. It's a triangle. So what I see now, I can just draw a height. The area of a triangle is 1/2 base times height. Okay. This makes a 30, 60, 90 triangle. This will be 10. Okay, that means x is 10. Our height will be 10 radical 3. So I'm just going to do 1/2 base times height for this problem. Area equals 1/2 our base, which is 20, times height, which is 10 radical 3, and that will give me 100 radical 3. Okay, if you feel like challenging yourself or you want to see how it works out with the apothem and perimeter problem, do that for me. Show me. Okay, we'll look at some practice with that with 2 and 3, and then you can go back and see, hey, how does this work with the triangle? You should get the same answer. All right, number 2. All right, doing the same thing. I'm going to draw my apothem in, make it 90 degrees. Okay, this is a quadrilateral or square, and so I can find the central angle because I'm going to say 360 divided by 4, which is 90. Okay, remember our apothem breaks that in half, so this makes this 45. We have a 45, 45, 90 triangle. Okay, it's given to us that our hypotenuse is 16, and so we can use our special right triangles to find out what the side and apothem are going to be. Alright, so I'm going to have to solve for this. I have that 16 equals x radical 2. I'll divide by radical 2. X will equal 16 over radical 2. Rationalize the denominator. And I get 16 radical 2 over 2, or 8 radical 2. So 8 radical 2 is our apothem. Also for this is 8 radical 2. This will also be 8 radical 2. So our side will be 16 radical 2. So we have the important parts of our problem now. I know my apothem, my area will be 1/2 the apothem, which I just found to be 8 radical 2. My perimeter will be one side 16 radical 2 times 4. So that is 64 radical 2. And so now I just multiply through. 8 times 64, okay, times 2, because radical 2 times radical 2 is 2, divided by 2. So 512. This area will be 512 centimeters squared. Got my units there. And then finally, last problem here. We're given a 1, 2, 3, 4, 5, 6, a hexagon. Hexagon again. Okay. So this is 60. 360 divided by 6. In this triangle, this will be 30. So this will be 60. So they gave us a special right triangle, a 30, 60, 90 triangle, where the angle across from 60 was 10 radical 3. Or sorry, the side across from the 60-degree angle was 10 radical 3. So we know that x radical 3 equals 10. And so using this equation pretty quickly, we can find that x is 10. So across from this is 10. Alright, so now we should find our side to be 20. And we can find the perimeter then, 20 times 6, which is 120. We already have our apothem, which is 10 radical 3. And so we can find the area. Area will equal 1/2 the apothem, 10 radical 3, times the perimeter, 120. And that gives us 600 radical 3. I'll double check that in my calculator just so I'm right. Yep. So our area for this figure would be 600 radical 3. I'll just say units squared since we're not given units. Okay, so hopefully you see finding the area using those special right triangles and those ratios to find missing lengths, and then using that to find the area of a triangle, multiplying that by how many congruent triangles there were, led us to the equation area equals 1/2 apothem times perimeter, and that is how we find the area of regular polygons. Okay, make sure you give it a try. See you tomorrow. We'll practice it.